Hello everyone, today is a new day, new life, new beginning, and new lesson. Once again, I'm Teacher Angie, your teacher for today. So our lesson for today is about variation. So what is the lesson about? Every day we are faced with different situations and problems. Sometimes situations involve quantities that are related to each other, such as distance covered by a bus and the fare, number of kilos of goods and the amount to be paid, and more. So it is important to discover the relationship that exists between quantities, which involves the concept of variation. So for our learning competencies, so the learners will be able to first illustrate situations that involve direct and direct square variations. Second, translate into variation statement a relationship between two quantities given by a mathematical equation. And last but not the least, solves problems involving variations. So what are the concepts of our lesson? First, indirect variation. Whenever a situation produces pairs of numbers in which ratio is constant, then there is a direct variation. So I'm going to discuss this later. The statements y varies directly as x, y is proportional to x, and y is directly proportional to x may be translated mathematically as y is equal to kx, and this is our variation equation. Remember guys, y is equal to kx is our variation equation, where k is the constant of the variation and y and x are the two given variables. So in here, a situation that produces pairs of numbers are the x and y. Okay, and the constant here, as we mentioned, is the k here. So when we say constant, it is already given here. Okay, always. Okay, next. Take note, to solve for k, you can use the equation k is equal to y over x. So if you buy the higher kilos of goods, the higher concept of direct square variation. So the expression y varies directly as the square of x can be expressed through the equation y is equal to kx squared, where k is the constant of variation, that is the ratio between x squared and y is directly proportional to x squared. So if you notice, this is the same with direct variation. The only differences, of course, is the variable x is squared. There is a 2 exponent here. Okay. Next, note, to solve for k, you can use the equation k is equal to y over x squared. Again, the steps in providing this is the same with direct variation. So we simply isolate k by the original equation, y is equal to kx squared. So to isolate k, we need to divide both sides by the variable beside it. So it is x squared. So both sides divide by x squared. Therefore, we have k is equal to y all over x squared. So for further understanding, we will be having our examples. Write an equation for the following statements. Number 1, the fare F of passenger varies directly as the distance d of her destination. So since the statement uses variable already, as fare is for F and distance is for d. So we will use those variable. So for our equation, we have F is equal to KD. So in here, it uses capital F, so we will use capital F. And of course, in here, it uses small d, so we will use small d. Or where do we get the k here. The k here is our constant. As I had mentioned a while ago in our previous slide, constant is always in there. So k is our constant. Next, number 2, the area A of a square varies directly as the square of its side s. Okay, again, it uses already variables. So area is A and side is s. And don't be confused with the two-word square here. This first square, this one, is talk about four-sided polygon with equal sides. Okay, and the square here is the exponent. Okay, so this example number 2 is an example of direct square variation. So for our equation, we have A is equal to KS squared. Why? Because it mentioned here square of its side s. Therefore, our s here, it has an exponent 2. Again, k is constant, always there. Next example, example B, write an equation where y varies directly as x and find the constant k. Okay, how? So for example number 1, y is equal to 28 when x is equal to 7. So y and x, or the two variables, are already given. So we will write first our equation, which is y varies directly as x. So we have now y is equal to kx. So this is our variation equation. Then after that, to find our k, divide both sides by the variable beside k. So divide both sides by x. Therefore, we have y over x is equal to kx over x. Cancelled x and x. Therefore, we have k is equal to y over x. Next, substitute the given. So k is equal to, our y is 28 all over our x is 7. Therefore, we have 28 divided by 7 is equal to 4. Therefore, our k is equal to 4. Next example, example number 2, k is equal to 10 and x is equal to 24. The same step, using our equation y is equal to kx from the instruction. Then, of course, in finding the value of k, we need to divide both sides by x and isolate k. Therefore, our k now is k is equal to y all over x. Again, as I mentioned a while ago, if you already memorized the formula, you can directly use it. Then after that, substitute k now is equal to, our y is 10 divided by our x is 24. Since 10 and 24 are both divisible by 2, then we need to divide both sides by 2. Therefore, 10 divided by 2 all over 24 divided by 2. So we have now k is equal to 5 over 12. Example, letter C. Solve the following. Find the unknown. So for number 1, if y varies directly as x and y is equal to 36 and x is equal to 9, what will be the value of x when y is equal to 48? So in here, we have already 3 given and 1 unknown. So first, we need to find the given. So in here, for y sub 1, we have 36. X sub 1, we have 9. Y sub 2 is equal to 48. And for x sub 2, it is our unknown. Next, for our equation, of course, y is equal to kx is our variation because it says here y varies directly as x. And from that original equation, we can find the constant k is equal to y all over x. And again, in such situation or problems, we cannot only use one solution. So we have a lot of solutions. So I'm going to add the equation ratio and proportion. Y sub 1 over x sub 1 is equal to y sub 2 over x sub 2. For our solution 1, first we need to find the value of k. So k is equal to y sub 1 over x sub 1. This one, constant. Why we have y sub 1 and x sub 1? But in here, we have only y over x. So to find 4k, we need to use first the first given. That's why we have y sub 1 and x sub 1. Remember that. Then after that, we need to substitute. So k now is equal to y sub 1 is 36 and x sub 1 is 9. Then divide 36 divided by 9. We have now 4 as our k. Next, we need to solve for x sub 2, our unknown. Again, since we have already our k, so we will use now our variation equation, y is equal to kx. So, why do we have 2 here? Again, we're looking for our y sub 2 or the unknown. That's why we have y sub 2 is equal to kx sub 2. Next, substitute the given. Our y sub 2 is 48 is equal to our k is 4. So k here, we need to change it by here. Okay, which is 4. And then copy x sub 2, the unknown. Then after that, we need to isolate x sub 2. Therefore, we're going to divide both sides by the number besides x sub 2. So we have now 48 divided by 4 is equal to 4x sub 2 divided by 4. So cancel 4 and 4. Therefore, we have x sub 2 is equal to 48 divided by 4 is 12. So we already find the value of k and x sub 2. Next, we're going to use another solution except variation equation. What is it? We're going to use the ratio and proportion. Let us see if they have the same answer. So using the equation y sub 1 over x sub 1 is equal to y sub 2 all over x sub 2 since they are direct variation. Then substitute the given. For y sub 1 we have 36 and x sub 1 is 9. Y sub 2 is 48 all over our unknown x sub 2. Then cross product. So 36 times x sub 2 and 9 times 48. Okay, so we have now 36x sub 2 is equal to 48 times 9. To isolate x sub 2, we need to divide both sides by 36. Of course, 48 times 9 is 432. So cancel now, see 36 and 36. So we have now x sub 2 is equal to 432 divided by 36, which is x sub 2 is 12. So if you notice, they have the same answer. So either of the two, you can use it to answer this problem. But of course, since we're talking about variation, so you can use the variation. But if the teacher told you to use the same solution, then you can use it. Okay, next. For our example number 2, if y is directly proportional to x squared and y is equal to 8, when x is equal to 3, find y when x is equal to 5. First, we need to find the given. So y sub 1 is equal to 8, x sub 1 squared is equal to 3, y sub 2 is our unknown, and for x sub 2 squared is equal to 5. And for our equation from the problem, we have y is directly proportional to x squared. Therefore, we have y is equal to kx squared. And for our constant, from here, we will find k is equal to y sub 1 all over x sub 1 squared. And for our ratio and proportion formula or equation, we have y sub 1 over x sub 1 squared is equal to y sub 2 over x sub 2 squared. And for our solution 1, first we need to find for k. So we have k is equal to y sub 1 over x sub 1 squared. Then substitute the given. K is equal to y sub 1 is 8 all over x sub 1 is 3 and then the exponent 2. In here, we need to perform first the exponent by following the order of operation. So we have now k is equal to 3 squared is equal to 9. Therefore, we have 8 over 9 as our k. Next, solving for the unknown y sub 2. First, we need to copy the formula. Y sub 2 is equal to k x sub 2 squared. Why there is 2? Because we're going to use the second pair of given. So we have now y sub 2 is equal to our k, which is 8 over 9, times x sub 2 is 5, and then the exponent 2. Again, we need to perform first the exponent 5 squared. So we have now y sub 2 is equal to 8 over 9 times 5 squared is 25. And then in here, by following the order of operation, multiplying fraction to whole number, multiply the numerator to the whole number. So we have 8 times 25 divided by the denominator 9. So we have now 200 all over 9. And 200 divided by 9 is equal to 22.2, which is our y sub 2. Next, solution number 2, using ratio and proportion. So first, copy the equation. Y sub 1 all over x sub 1 squared is equal to y sub 2 all over x sub 2 squared. Then substitute the given. So we have now 8 all over 3 squared is equal to y sub 2 over 5 squared. Again, perform first the exponent. So we have now 8 all over 3 times 3 is 9 or 3 squared is equal to y sub 2, 5 squared or 5 times 5 is equal to 25. Then cross product. So 8 times 25 and 9 times y sub 2. So we have 9y sub 2 is equal to 8 times 25. To isolate y sub 2, we're going to divide both sides by the number beside it, which is 9. So we have now 9y sub 2 is equal to 8 times 25 is 200. So isolate now y sub 2, we have 9y sub 2 over 9 is equal to 200 divided by 9. So cancel 9 and 9. So we have now y sub 2 is equal to 200 divided by 9, which is 22.2. So if you notice, they have the same answer. So either of the first solution or the second solution of the problem is the same. Okay? Okay, so the same with a real life situation. Sometimes we have different problems, but we have the same solutions. Okay, next. Again, before I'm going to give you exercises, so we're going to review first. So whenever a situation produces pairs of numbers in which the ratio is constant, there is a direct variation, which is our lesson for today, or direct square variation. So these are the equations that we need to remember. So for direct variation, y is equal to kx for the variation equation. K is equal to y all over x is for our constant, and y sub 1 all over x sub 1 is equal to y sub 2 all over x sub 2 is for our ratio and proportion. And for the direct square variation, for our variation equation, we have y is equal to kx squared. And for our constant, we have k is equal to y sub 1 over x sub 1 squared. And for our ratio and proportion, of course, y sub 1 all over x sub 1 squared is equal to y sub 2 all over x sub 2 squared. And of course, terms used varies directly as, is proportional to, and is directly proportional to. So when you hear these terms, you're talking already to direct variation. Okay, next, these are your exercises. So for practice number 1, write an equation for the following statements, 2 points each. Practice number 2, write an equation where y varies directly as x and find the constant k. 2.8. Okay, so that's all for today. I hope you learned something from me. If you have questions, just PM me and I'm going to answer you back. Please type your answers with complete solutions in our chat box. Good luck and God bless. Be well and keep safe. Bye.